number 1. I think we'll pretty much go in order here. So here we go. Take a look here. It says identify the intervals on which f of x is increasing or decreasing for the function f of x equals 27x minus x cubed. Justify your answer. So this would absolutely not be a calculator question. So for those of you that, if you're like me when I was in high school, I would think things like, oh, I'll just graph it. Increasing, decreasing, right? We're good. This would definitely be a no calculator type of a question. So I would love to give you guys a chance to try to explore with this a little bit. Like if you know those two statements that I just told you from the video, if f prime is positive, f is increasing. If f prime is negative, f is decreasing. If you know those two, you actually already sort of kind of have all the tools that you need to do this one. There might be a few blanks I could kind of fill in for you, but I'm kind of curious. Can you do this, or how far can you get with this without a calculator? Ready to go. I'll give you like 3-4 minutes, maybe 5 minutes to just try to explore with this a little bit. I'll definitely make sure that you know what you're doing before we're done with this. Let's see how much you can do right now, working together or working on your own. Ready to go. Yes, ma'am. Can we do what? So let's go over this one. We're gonna kind of follow this pattern with most of these here. So you guys will get a chance to kind of go off on your own a little bit as well on some of these others. But let's go ahead and do this one here. Again, the understanding the framework of the logic behind this should give you direction. So guys, it's not really a word problem, but we could sort of make it a word problem. If I'm looking for where f of x is increasing or decreasing, maybe I underline those, that's my objective, right? What if I did this? What if I was like so well versed on how these things relate to each other? What if I said, wait a minute, f of x is increasing? That means that f prime would probably need to be positive. F of x being decreasing, I'd probably be looking for where f prime is negative. That makes sense? What if I labeled my question like this and made that connection between f of x being increasing and f prime being positive? Kind of like I've written up there. It might be a good place to start, right? So here's my thinking. If f prime is what I'm focusing on, I better have something for f prime. And right now I don't. The only thing I have is for f. So how do I go from f to f prime? Do a derivative, yeah. So the derivative of f would get me to f prime. F prime of x then, according to the power rule, would be 27 minus 3x squared. That make sense? Let's understand the logic and the concept behind it. I'm not finding f prime because, duh, it's a calculus class. That's what we do. That's not why I'm finding it. The reason why I'm finding it is because I want to figure out where f prime is positive or negative. Because if I know that, I can answer my question pretty easily. That make sense? I want you to understand the logic framework behind it. So here's a really crucial step that we want to put. If I'm looking for where f prime is positive or negative, what's the number that divides the positives from the negatives? 0. So here's what I want to do. I want to write equals 0. I don't want to think that. I don't want to say that. I want to write that. And perhaps think it too. But you need to write that down. Because if you don't write that down, there's really not a solvable equation up there. Right? I want to set the f prime function, whatever it is, equal to 0. And now I'm going to solve. Because these numbers, especially since we have a continuous function, these numbers are going to be where f prime goes from a positive to a negative or from a negative to a positive, telling me what I want to know. So if I solve this, I get, 27 equals 3x squared. Dividing by 3, I get 9x squared. Or excuse me, 9 equals x squared. And then finally, I get plus or minus 3. Anybody get that far? Santi, you did? Okay, cool. All right, so x equals plus or minus 3 would be the places where f prime is 0. So I don't think I showed this in the video. I want to introduce you guys to a tool that might be helpful. I think that it really is. People tend to grab onto this. It's called a sign chart. I'm going to make what's called an f prime sign chart. Essentially, guys, it's a number line that allows me to figure some things out that I'll use here in a second. So on my sign chart, I'm going to put two different numbers. I'm going to put the -3 and the 3. The reason why I put that on the sign chart is because that is where f prime is 0. It's also going to be potentially where f prime changes from a negative to a positive or from a positive to a negative, telling me what I need to know, right? So then any ideas on how I could figure out? Basically, I've created 3 intervals. I've created a red interval, I've created a green interval, and I've created a blue interval. And if I can just figure out is f prime positive or negative in any one of those intervals, I'll be able to just go right to my conclusion, right? Any ideas on how I could figure out the sign of f prime on those intervals? What could I do? Say again?
Test a number from the region.
Just test one. Yeah, test one of the numbers in the region. So maybe over here, I test out, I don't know, say -4, -5, -6, -10, whatever. Any of those numbers in there will work. Let's do -4. So I'd say f prime of -4 equals what? Say again? -21. Got it. Okay, so then I'm going to put up here a little minus sign telling me that f prime is negative on that whole interval. What might be the most wise test value for the middle interval? 0. There we go. F prime of 0 equals what? 27, which is positive. So on that middle interval, f prime is positive. And on the blue interval, you might assume that f prime changes signs. Don't want to assume. It actually does. Maybe we try a 4. F prime of 4 equals what? -21 again. I think you're right. There is some symmetry there. Won't always be that way. We are definitely not done. So pause for a second. Question? No. Okay. Okay, cool. All right, so then here's how we would close this one up. We're going to put in, it does say these keywords right here, justify your answer. So we're going to conclude. And this is this is like the writing portion of the class. It's not very much writing. Basically a couple of sentences. So what I'm going to do is this. My conclusion is f is increasing. I'll just put INCR for increasing. F is increasing on what interval?
Infinity to -3.
I disagree.
Oh, I mean -3 to 3.
It's that middle interval, right? Yeah. So -3 to 3. Now the justification is essentially give me a really good reason why you're saying what you're saying. What do you think?
F prime of the 0, which is indeterminate, is positive.
Let's just say f prime of x, because we know that the property for f prime of 0 would hold true for all the numbers on that interval. So f prime of x is positive on the interval -3 to 3. So I'm showing you, Anna asked about this earlier, I'm showing you guys really good notation on the whole open-closed interval, like brackets and parentheses. I'm not going to judge you on that. So like if you put parentheses and it should have been brackets, or you put the other way around, I can still give you full credit as long as you have the right interval. Okay? And then the other piece here did ask for where f is decreasing. So I would say f is decreasing, DECR for decreasing. Well, gosh, it's 2 intervals, isn't it? So it would be -infinity to -3 and 3 to positive infinity. Of course, you do have to be open on the infinities there. And it does want a justification, of course. So because why? Yeah, f prime is negative on those intervals. Let me try that again. And you can just put those intervals if you want, or you can repeat yourself, whatever. That's either one of those is okay. Anna, go ahead.
So besides like the justify your answer part on like this side, for one that was like that where like the numbers were pretty simple, like did you have to write out like where you did those regions, or if you like looked at it and you could just say that like you knew that if that was greater than like if x had an absolute value like greater than 3, it was going to be negative?
Sure. Let's talk about, so what do you got to show?
Yeah.
Right, yeah, that's a good question. Okay, so what would you have to show here? In other words, like where would you be collecting points or not for a question like this? I hope that this will make sense to you. So anything I highlight in blue, I think you really got to have. So you need to have this right here. You got to show me that you've set f prime equal to 0. Like that needs to be written on your paper. And then, honestly, all this stuff, I frankly don't care. It's algebra. It doesn't mean that it's easy. But if you could take that equation and solve it in your head and be like, oh, plus minus 3, that's cool. You don't have to show that. You don't have to show the sign chart. The sign chart is never going to be the make or break for you. You don't have to show that. But I do need to see some kind of evidence like that-ish. Sort of, kind of, doesn't have to be in that exact same format. Could just be in a table. It could be sort of scatterbrained all over the place. I mean, please don't do that. But, it needs to be there. And let me explain why. Because when you get over here, like this stuff in the blue box really has to be there. Right? Because you're identifying the answer and you're giving a justification. But I should be able to look at what you have here on the because f prime is positive on negative 3 to 3, and I should be able to identify some evidence that gives you some standing to say that. And if I don't see this in this blue box right there in the middle, if I don't see that, then all of a sudden when I'm like, well, wait a minute, how does she know that f prime is positive anywhere in there? How do I know that she's not just taking a lucky guess? Because she could have just guessed. Or not, I don't know. But if you've got some evidence there, I'm like, oh, I can totally see why she would say that. So I'd say the stuff in the blue boxes. So you can skip the sign chart entirely, although I think it is valuable. You can skip some of the algebra in there. You can't skip the whole f prime equals 0 stuff. Did I get your question? Okay, cool. Any other questions? Is this pace okay for you? I'm not trying to rush. I'm not trying to go like excessively slow either. We doing okay? Any questions? Okay, I want you guys to take a look at example number 2 now. If you guys would, again, try this on your own or with a friend. Either way works for me. I'll read it out loud to you. Hopefully you'll get the stuff you need from this. Use the graph of G prime to determine the intervals on which G is decreasing. And notice I've labeled that graph with a G prime. And I didn't put this on here, but let's just get the practice. Will you guys, you don't have to write this down if you don't want to, but do this. Justify your answer. Kind of like we did on the other one. Give a reason for what you're saying. Okay, let me remind you kind of the big takeaway for today. We're not going to have any of the big takeaways for today. Here it is. If f prime is positive, f is increasing. If f prime is negative, f is decreasing. Again, if f prime is positive, f is increasing. If f prime is negative, f is decreasing. Okay, so I would encourage you, you have all the elements that you need there, but it's a little ambiguous. Think about using complete sentences. I think that's going to be your best bet. And I'll point something out on this one here too. I should have pointed it out on
Can you
number
just say
one.
because it's negative on the graph because you didn't prove that it was negative?
Right. So be super careful with your. Hope you did. So here's what I'm thinking. Again, you guys are just learning this. It would be a great idea to mark this question up. So maybe what you do is you say, all right, I'm looking for where G is decreasing, and I'm hoping that you would immediately make the connection and say, oh, I know what I'm doing. I'm looking for where G prime is negative. Does that make sense? When G prime is negative, G is decreasing. So really, to be honest with you, this is where, you remember all that work we've put into drawing these graphs of derivatives? This is where some of this will hopefully start to pay off. Aren't I really looking for places where G prime is below the x-axis? So any interval that is in that blue shaded region would be what I'm looking for, and anything that's not in that blue shaded region is not what I'm looking for. That make sense? Okay. So walking around talking to you guys, I saw some really nice examples. Maybe we say something like this. G is decreasing on the intervals from -2 to 2 and 4 to 5. Because why? Because why?
Because G prime is less than 0.
There you go. G prime is negative on those intervals. Did anybody else have, instead of a 5 right there, have an infinity? It's really easy to do that, and typically that's not going to take you out of any points. But the truth is, we don't have a clue what's going on with this graph beyond 5. We'd like to assume that it just continues on the pattern that we see there, but we don't know, frankly. We do know what's going on up till 5, so we can for sure put that, but I would hesitate to extend all the way to infinity unless we actually know the pattern of what's going on, which could happen. We just don't know it here. Can I point out some really decent sounding wording that's actually really bad? Ready? So check this out. G is decreasing on the same intervals and blah, 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 because it is negative on those intervals. What is so bad about that? Say again? Yes, well said. This sounds like an English person right here, like somebody knows how to write a little bit of English. Pronouns need antecedents, don't they? Sorry to bring your nightmares from English into math. But pronouns, like the word it is a pronoun and it needs an antecedent. The only antecedent in there is G. So you're essentially saying G is decreasing because G is negative. Now that's actually wrong. This would actually not earn you credit. So please, I'll put it up here and I'll zoom in on it for you. Please do not use the word it unless you're prepared for me to search through and try to figure out what it actually means. It'd be so much better for you to say G is decreasing on those intervals because G prime is negative, right? You're being specific, right, instead of generic. So be specific like that. No its, and I think you'll be. And I think what you're going to find is if you're forced to use proper names, it might actually improve your writing a little bit. Make sense? And let's be honest, isn't it easier to write G prime than it is to write it? It takes more marks with your pen. G prime is faster. Can I point out one other issue here? What if I did this? And this comes up sometimes. What if I wrote this? I said G is decreasing on the interval from -2 to 2 and 4 to 5 because F prime is negative on those intervals. This is a really common one also. What's so bad about this?
It's different functions.
Yeah, F prime does not have anything to do with G necessarily, at least that we know of. It could, but we don't know what that connection would be here. So there are certainly some times when you'd still get credit. Like if the only function is G, I'm going to just assume that you misspelled G prime with an F and perhaps give you credit for it. But if there's more than one function going on, and that will happen a lot, you definitely would not earn credit because you're making the wrong connection. So please do, and this is another kind of an it thing. Just be careful that you're not being too generic, or in this case, just naming the wrong thing. Okay. Any questions? All right. I think we got an application next. Is that right? Application. Here we go. Yes. Okay, grass clippings. This is actually an old AP question, and the calculator is definitely active. So grab your calculator. Yeah, calculator definitely active here. Sorry I didn't put that. So grass clippings are placed in a bin where they decompose. Sort of unpleasant, whatever. For the interval from 0 to 30, the amount of grass clippings remaining in the bin is modeled by that function, where A of t is measured in pounds, t is measured in days. Find the value of A prime of 15. To me, that's the calculator part. We haven't talked about how to differentiate an exponential yet, so we definitely want to use the calculator for A prime of 15. But then, using correct units, interpret the meaning of the value in the context of the problem. So take a minute here to calculate that value. Yeah, Alex. I probably do. The stuff we've already, I think, confirmed. So I'm going to say A prime of 15 equals, it was negative 0.16 what? 4? Okay. So we go with the 3 decimal thing there. So there's that. And if this were some test question, then, that would at least earn you the first point, right? But now we want to get this explanation in as well. Give you just another moment here to get something down on paper. It's really important that you try to write it down. Don't just think it or say it to your friend. Try to write it down.
Are we supposed to use units? So would it be like pounds?
Yeah, so AFT is measured in pounds, T is measured in days.
Okay.
Yeah, totally. I was just mostly hoping I didn't forget to put that in the question. There. Okay, so I'm wondering if anybody wants to be bold and brave and maybe throw out a proposal. Like, here's what I think the interpretation would be. Anna, go ahead.
I would have written that A of T, or A prime of T, is the rate of pounds of clippings in the bin over time, just measured in days, so about parentheses days, and that at T equals 15, A prime of 15 is equal to negative 0.164.
Yep.
So at T equals 15, the clippings are decreasing at a rate of negative 0.164 pounds per day.
Ooh, cool. Okay, so I really like what you said. Could you say it a little bit slower? I want to write down exactly what you said. T equals 15. The clippings are decreasing. Am I right?
Yeah, after I said that T equals 15, I said A prime of 15 is equal to that.
Negative, yep, I got that.
So that at T equals 15, the clippings are decreasing at a rate of negative 0.164 pounds.
Kind of trailed off there. You said pounds?
Yeah.
Okay. Per day. Okay. Want to
I guess
make
you wouldn't need to put the negative because you said decreasing.
So we'll discuss that, right? Because that could be important. Okay, so I went a little bit slightly different order perhaps than what you did because I already had the A prime of 15 equals negative 0.164. What do you guys think? I think there's stuff at least to discuss. Do you agree? Do you disagree? Is it close? Would you change anything? Anna already kind of suggested a change. She's like, well, what about the negative and the decreasing thing?
Yeah, I would.
Okay. What do you all think? Anna was really bold and brave, and she'll be okay if you.
have to say that it's the rate of, like you have to say rate of negative 0.164.
Good question. I think I'm definitely a fan of the word rate being in there, simply because A prime, like prime, indicates that it's a rate of change. So I would say, yeah, I like that idea, for sure. How young?
If you're putting decreasing, do you have to put the negative?
So yeah, and of course, Anna already brought that up, so let's talk about that. As this is currently written, it would not earn full credit because of that, because of the double negative, right? If something is decreasing at a negative rate, think about that. If something is decreasing at a negative rate, isn't it actually increasing? It's really a double negative. And so I agree with you, Anna. Go back and fix that. I think I would just make it the clippings, the amount of clippings is decreasing at a rate of 0.164 pounds per day. The only other thing I would put in here, I think would be important for us to note, is the 15 actually has its own units as well. It's when T equals 15 days. I think I'd highlight that and make sure I put that in there. When T equals 15 days, the clippings are decreasing at a rate of 0.164 pounds per day. And of course, we're comfortable saying this because the rate that we found is negative, right? So that might be useful to put that as well. And I think Anna kind of mentioned that. She said, hey, the rate is negative. And then she went on to say that the amount of clippings were decreasing. Yeah. Okay, so this is not the most neat, wrapped up in a pretty packaged kind of a explanation, but this is pretty good. Like if you wrote this, I'd be fine with it. You're like, hey, I found A prime at 15. I know that A prime is the rate, so the amount must be decreasing when T equals 15 days at this 0.164 pounds per day rate. Again, Bailey said, does the word rate really have to be in there? You could probably skirt your way around it. You could probably figure out a way to not use the word rate. But I would say if you're trying to contextually define what a derivative is, I think the word rate should naturally fit in there, right? That makes sense? So don't try to avoid using the word rate. If it really is a rate, feel free to put it in there. Heather, go ahead.
Do you have to say anything about like instantaneous?
No, so we're kind of saying that when we say at,
That's
the 15th day. If you did say something like, hey, the instantaneous rate of change is this, fine with that, totally, but I don't think you have to put that. Yeah, Andy?
So do we have to do write out like whether it's decreasing or increasing every time?
I was glad that Anna said what she said, because I think this is the best, most contextual version. There are some more generic versions. I guess I'll just say them. So if you wanted to say something like A prime of 15 is the rate of change of grass clippings on day 15 in pounds per day or something, that's a little more generic. This is a little more specific and contextual because truly, because the rate of change is negative, then the amount's decreasing, right? So I think this is best. I have definitely seen tests, most of them, where they will take what you're suggesting. I just think this is the more contextual one. It's a good question. Okay, others? Any other thoughts, questions? I really appreciate you guys saying, what about this and what about that? I mean, that's kind of the only way to get that out. I'd love to be able to like read your mind and be like, oh, he's thinking this. I can't. So try as I might. Doesn't work. Anything else? Okay, fantastic. So let's do our final example here today. Another kind of an application style question. Yes. Yeah. So this sort of question will be a pretty common theme. And when I say this sort of question, I'm talking about this idea of competing rates, or sometimes people will refer to these as a net rate. So these always follow the same kind of theme. Essentially, it's this. There is a rate causing something to increase, and at the same time, there is a rate causing that same thing to decrease. Make sense? This is a classic one. You'll come to call this one the water tank question. There will be a lot of questions that are kind of like the water tank question. Let's read it really quick. You'll see what I mean by competing rates. It says the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7, where t is measured in hours. In this model, rates are given as follows. So here's some important rates. And this is very much of a word question, right? So maybe we underline the key rates. The rate at which water enters the tank is F of t, gallons per hour. And B, the rate at which water leaves the tank is G of t, again measured in gallons per hour. So you see how there's a tank and there's water flowing into it, but maybe there's a leak, or maybe there's a valve that's open and the water is also flowing out of the tank at the same time the water is flowing in from some other source. It's the water tank question. You see why I would call this a competing rates question? One rate is making the water increase, the other rate is making the water decrease. Okay. And yeah, there's even a piecewise in there, I get it. But I did draw you a graph. Pretty nice graph. The piecewise is just linear. So here we go. For the interval 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Justify your answer. So I want to kind of guide you through this a little bit, but I need you guys to supply some important details. I'm going to put a box around the objective like we've done before. Find the time intervals during which the amount of water in the tank is decreasing. Let me ask you a question. This is where you're going to help. Do we have a function describing the amount of water in the tank?
No.
We do not. It's mentioned in there. Do you see how it says, the very first sentence, right at the top there, it says, the amount of water in a storage tank in gallons is modeled by a continuous function. But notice it doesn't give you that function or even give you a name for it, right? Are you guys okay if we just name it? What would you guys say? What would be a good letter to name this function? W of t for amount of water? Okay, I'm fine with that. So what if I said W of t equals the amount of water in the tank? W of t equals the amount of water. Still okay with that? Yes, sir.
Can we just do like when the amount of water?
Yeah, I think I know where you're. I think you probably should have said rate.
Yeah.
But don't go there yet. Don't go there yet. So Andy, your idea is not bad. I want to see if we can all of us get there. I think maybe you've seen something a little bit quicker, which is fine. Are you guys okay with that? And Andy, you'll see the connection here in a second if we're talking about the same thing. So if I'm looking for where the amount of water is decreasing, couldn't I say I'm looking for where W is decreasing? Okay, so here's your big connection. W would be decreasing when
W prime of T
is
less than 0.
negative. There we go. Okay, so W prime of T being negative. That's what I'm looking for. I'm looking for this. So I'll just put this right here. Go ahead.
Could you say that like W of T would be equal to like F of T minus G of T?
Let's go there. Let's go there. Not quite. Let's talk about why this is. So she just said, would W of T equal F of T minus G of T? And here's the truth. She is really close. But if we...
Have to include how much water is in it?
No, no. If we take a look at the units, we can see that as close as you are, there's an important gap that we need to fill. What would be the units for W of T, which is the amount of water? Gallons. What are the units for F of T? Gallons per hour.
W prime of T equals G of T minus F of T? Or the other way around?
Audrey, I think the answer to your question is yes. So W of T measured in gallons can't be equal to gallons per hour, right? Gallons is literally an amount of water, whereas gallons per hour is the rate of change of that amount of water, right? Like if you said, hey, Mr. Anderson, I heard you're a really fast runner. Listen, if you said, I heard you're a really fast runner, how fast can you run? And I respond with 20 miles.
That'd be so sick.
Do you see how I've answered with the wrong sort of thing? What would have been a more appropriate answer? 20 miles per hour. How fast can you run? Now, if you said, how far can you run? And I'm like, 15 miles per hour. Again, aren't I answering with sort of the wrong category? I've answered with a rate when you ask for an amount. So W is an amount, and so I can't really say that an amount equals the difference of the rates. But what I could say, going back to what Audrey suggested, is I could say that W prime equals F of T minus G of T, because W prime is the rate of change, which is actually gallons per hour with the units. So this is a challenging question in some regard, because what you're going to find, I see your hand, hang on. What you're going to find is, as weird as it is, on this question, you simply don't have to calculate the derivative at all. It's already been given to you, hasn't it? Aren't F and G the derivatives of the amount of water? And this is where people get uncomfortable, because they're like, it's a calculus class, I better be finding derivatives. The truth is, the derivatives of the amount of water were given to you. We don't have to do any extra differentiating to get where we want to go.
Since it's over two intervals, if you do two equations, like 1 through 0 to 3 and 1 through 3.
We'll get there in a second. Santi, what was your question?
Wouldn't it be G of T minus F of T because you want the water, the water going out to be bigger than the water going in?
Well, let's talk that over. So I think I like the way that it's set up, and here's why. F of T is the rate at which water enters the tank, right? So isn't F of T causing the amount of water to increase? Therefore, that should be a positive rate.
No.
But G of T is the rate at which water leaves the tank, causing the amount of water in the tank to decrease. So I would say G of T would need to be the negative. So that's why I do F minus G. I'm not saying that your strategy is a bad strategy. I think this will be a better consistent strategy. Okay, so here's how we finish this one up. If I'm looking for where W prime is negative, I probably would want to find out where W prime is 0, right? So what I'm going to do here, this is always going to be a key transition for us. I'm always going to put that the net rate is equal to 0. You've got this graph right here, so it's kind of nice. You guys see any places in there where W prime would equal 0? I don't think so. On the graph, what are we looking for? The intersection points, yes. So there and there, those are for sure going to be zeros. We got that jump in the middle, the 3, right? So the 3 might also be an important thing to consider as well. How are we supposed to find those intersection points? Plug what into what? No, how do you, no?
Have you set the functions equal to each other?
Yeah, the calculator would be active here.
Like if you could graph it, but couldn't you set like 250 equal to f of t and you
Sure.
find that intersection in there.
Yeah, totally. Yeah, so I'd use a graph. I would find the intersection point on the graph. I really would. Anybody done that yet? Let's do it. Let's roll. Come on. We just have a couple of minutes. You're going to want to push some buttons and push them pretty fast. So clearly the first intersection point is somewhere between 1 and 2. The second one, it looks like it's pretty darn close to 5. It's kind of hard to tell which side of 5 it's on. Anybody have that first intersection point? Once you've got it, just shout it out. How we doing? Anybody have it? Let's finish this sucker up. 1.617 sounds very reasonable. And then how about that other one that's closer to 5? Usually when you have these graphs and you have to use your calculator to help solve something, I usually just try to match the window on my calculator, like Stu's saying. I'll try to match the window on my calculator with the window that I see right there. Should end up looking the same. 5.076. Again, sounds pretty reasonable. So guys, we can finish this one up pretty quickly. Let's finish it up. I'm going to consider those points right there. And I know that f of t is my curvy graph, and g of t is my piecewise linear. So here we go. Would you guys agree that from 0 to that 1.6 number, wouldn't you guys agree that g of t is bigger than f of t? I'm talking about this interval, this nice, lovely blue interval right there. You guys see how g of t is bigger? So f of t minus g of t would be? Oh, let's finish. If g of t is bigger than f of t right there, then f minus g would have to be? Negative. Okay, that's what we were looking for. So I would say that w is decreasing on 0 to 1.617. There could be others. Let's keep going. So how about this lovely red interval from here to here? Would you guys agree there that f is bigger than g on the red interval? So f minus g would be? Which is not what we're looking for. So I'll skip that one. Then on this lovely purple interval, would you guys agree with me that g is bigger than f? Therefore, f minus g would be? Hey, there's another interval, right? So on the interval from 0 to 1.617 and from 3 to 5.076, what about that last one? You guys see how f is bigger than g? So that's going to be where the net rate is positive. So we're done with our intervals. So w is decreasing on those intervals because w prime is what? Negative on those intervals.
Is that a sufficient justification?
Definitely. Because we have the graph in front of us and the calculator's active, I don't need to see any test values. If the calculator's not active, I got to see some test values, but I see that you got that graph right in front of you, so we should be good. You guys see how we scaffolded this? See how the first one was like pretty easy? And we like kind of ramped our way all the way up to this one. This was the toughest one. So hope that makes sense to you guys. Have a wonderful day. I look forward to seeing you on Wednesday. If you need to, go back and watch the intro video for Wednesday, the second part, because we'll do the maxes and mins that you saw. We'll do that on Wednesday. See you guys.
Yeah.